Hello, in this video I'm going to explain you what a power is, the type of powers we have, and the properties with them. Let's start with the definition of a power. A power is a multiplication of a number by itself n times, as we see here. Let's say that we have 3 times 3 times 3 times 3 times 3 5 times. We see that number 3 is multiplied by itself 5 times. So we will write 3 to the 5th. Here we have the exponent, as here we say. The exponent in this case is number 5, and it shows you many times it is being multiplied. In this case, 5 times. This is the base, as here we see, and it is the number that we have multiplied. Okay? Now what happens if we have a negative number in the base and, for example, let's say to the 3rd? Here we know that the number that is being multiplied by itself is -2, so it is negative. So here, if we operate this, if we multiply these numbers, we get 2 times 2, 4 times 2, 8, and that of the signs, we have 3 negative. So that means that minus times minus is plus, times minus is minus. So that means that the result in this case is -8. If we had -2 to the 4th, then we have -2 times -2 times -2 times -2 4 times, which means that we have 2 times 2, 4 times 2, 8 times 2, 16. And now minus times minus, plus times minus, minus times minus, plus. So the result in this case is positive 16 or 16. So to sum up, when the exponent is an even number and the base is negative, the result is always positive, because here we have -3 times -3, 3 times 3 is 9, and minus times minus is plus. What happens if it is an odd number, the exponent? Here it's an odd number, 3, 1, 3, 5, 7, so on. And of course, the base of the power must be a negative number. So in that case, the result is negative, because in this case, what we have is 3 times -3 times -3. 3 times 3, 9, times 3, 27, and minus times minus is plus, times minus is minus. It is negative. So if the exponent is an even number and the base is negative, the result is always positive. And if the exponent is an odd number and the base is negative, the result is always negative. Let's start with the properties of powers. Here we have the first one. It is called the product of powers of the same base. What happens if we have two powers, different powers, for example, 2 to the 5th times 3 to the 4th? These powers are being multiplied by each other. If we write in a multiplication form, 3 to the 5th is 3 times 3 times 3 times 3 times 3. And 3 to the 4th is 3 times 3 times 3 times 3, 4 times. If we look at this expression, we see that we have here 9 3s. So the 3 is being multiplied by itself 9 times. So it means that what we have is 3 to the 9th. Okay, so if we have a product of powers of the same base, instead of doing this, what we've done here, we can just add the exponents up, and we will have the same result. This is the first property. For example, let's say 2 to the second times 2 times 2 to the fourth. Okay, here we have 3 powers. Well, it doesn't matter because all of them have the same base. So what we have to do is, okay, we write the base 2, and now we add all the exponents up. Which are the exponents? Here we have 2, here we have 4, and here we don't have anything, which means that what we have is 1, because 2 is 2 to the first. We normally don't write 2 to the first, we write just 2. So what we have to do here is 2 plus 1 plus 4. So the result would be 2 to the 7th. Here we have the second property, the division of powers of the same base. In this case, we have 3 to the 5th over 3 to the 2nd, for example. What we have is 3 times 3 times 3 times 3 times 3, 5 times, over 3 times 3. Okay, in this case, we can remove these 2 3's because if we multiply something, for example, I am multiplying 5 times 3 over 3, we get 5. It is like multiplying by 1 because 3 over 3 is 1. So that's why in this case I can remove these 2 first 3's and so these ones. So we will have 3 times 3 times 3, which is 3 to the 3rd. So if we look at this expression and at the result, we realize that when we have 2 powers of the same base that are being divided, we can directly subtract the exponents, so we have the same result. What happens if we have a power of a power, for example, 2 to the 2nd to the 3rd? Here I'm saying that I have 2 to the 2nd is 2 times 2, right? And here, with this exponent, I'm saying that of the parentheses is being repeated 3 times because the exponent is saying how many times we are multiplying by itself. So 3 times 2 times 2. 2 times 2 times 2 times 2. As I've said, this is 2 to the 2nd, 2 to the 2nd, 2 to the 2nd, and it's being repeated how many times? 3 times because this exponent is saying so. So in total, how many 2's do I have here? 1, 2, 3, 4, 5, 6. 2 to the 6th. So when we have a power of a power, we can multiply the exponents 2 times 3, which would be 6, and we get the same result. This is what this property is telling us. Fourth property, the power of a product. If we have 2 times 3 and everything to the 2nd, for example, this property is saying that I can do this, I can multiply 2 times 3 is 6 to the 2nd, which is 6 times 6, 36, right? But we also can do 2 to the 2nd times 3 to the 2nd. It's like we are raising the first one to the exponent and then the second one. And as both are being multiplied, I also must write the multiplication. So let's see if we get the same result. 2 to the 2nd is 4 and 3 to the 2nd is 9. And 4 times 9 is 36. So we get the same result. So I can first multiply the numbers and then raise the result to the exponent, or I can raise each number to the exponent we have and then finally we multiply them. Here I have the last property. It is the power of a division. It is very similar to the last one. Here we have 15, for example, over 3 and everything to the 2nd. Okay? 15 over 3 is 5, to the 2nd is 25. 5 times 5. Okay? This property is telling me that I can't just do first the division and then raise it to the result. I will raise it to the 2nd power, or I can do 15 to the second over 3 to the second, and we should get the same result. So 15 to the second is 225, and 3 to the second is 9. Now 225 over 9 is 25. So we see that we get the same result. Last things, when we have a number, any number to 0, what we have is 1. It is not 0, it's 1. Where does this come from? For example, we have 3 to the second over 3 to the second. If we write these powers in multiplication form, we have that 9 over 9 is 1, right? But we know that we also can use the properties of powers. In this case, the bases are the same, and as I have a division, I can subtract the exponents. So I would have 3 to the 0. So when we have any number 2 and the exponent is 0, the result is always 1.